Okay, let me start. What's probability? And then probability is always the favorite outcome over the total outcome. For example, if we're rolling a dice, what is the probability when you're rolling a dice that they show up, for example, 3? How many 3 we have in a dice from 1 to 6?
1.
Just 1. What is the total outcomes?
6.
6. Okay. Okay, let me start doing the probabilities now with the dice. Okay, as you know, the sample space is 1, 2, 3, 4, 5, and 6, okay? And then this is the probability with this dice. Okay, what is the probability that you're getting, for example, 5?
1/6.
1/6. What is the probability that you're getting num 5?
5/6.
5/6. What is the probability that you're getting 7?
0.
0.
0. It's impossible to happen. All right. What is the probability of getting an even number?
1/2.
What are the even numbers?
2, 4.
4, 6. And then this is 3/6. We simplify 1, 2, which is 1/2. Remember something. We can write the probability as a fraction, okay? We can write the probability as a decimal, okay? Or we can write the probability time multiply the decimal point times 100 and you get, which is 50%. And you can write it in percentage too. There are 3 different ways to write probability. That depends on the multiple choice option that you have. Okay? Got it, everyone?
Yeah.
What is the probability of getting an up number? Up. What are the up numbers?
1, 3,
1, 3, 5.
5.
And then the probability of getting another number will be the same, 1 and 2, right?
Mm-hmm.
Then what is the probability of getting a prime number? Put your mind mute, prices. You have something surrounding you. Put your mind mute. What is the probability of getting a prime number? What are the prime numbers? Hello? Hello? Are you there?
It's 2, 3.
Okay. The prime numbers are
2,
2,
3,
3,
and 5.
and 5. Does 1 is a prime number?
The numbers that you can't, it can only be multiplied by 1 and the number, right?
The prime numbers are the number that are divided by 1 and by themselves. Does 1 is a prime number?
Yes.
That's my question. 1 is a prime number? Yes or no?
Yes, no.
No.
No. A prime number can only be divided without a remainder by itself, starting from 2, okay? This is the prime numbers. I will be sending this one to you. Okay. And then it's the same probability, all right? 1 and 2, okay? Because it's a 3 over 6, so you simplify that, you get 1 and 2. Okay, let me go now, and then let's play the probabilities with a coin. Okay, what is the probability of getting help?
0.5, 1/2.
Which is 1 over 2, which is 0.5, which is 50%. The same thing of getting tails, okay? And now, what is the probability? What is the probability that you getting two help after flipping a coin twice? Okay, what is the probability that you get two help after you flipping the coin you flipping the coin twice? Okay, the probability of flipping the coin and you get the coins twice and you get help is, what is my sample space? Let's get the sample space. Let me suppose the first time you get help,
head,
and then
tail,
help,
head, tail,
and then
tail,
tail, help, and then tail.
tail.
What is the probability? Probability is just 1 in 4. Okay, which is my 0.25%, which is 25%. Let me show you another way to do the same thing. The probability of getting help twice, you can multiply the probabilities individually. Okay, we multiply the probability of getting help times the probability of getting help. What is the probability of getting help? 1 over 2, right? Times the probability of getting help, 1 over 2, which is 1 over 4. Two different ways to do the same thing. Okay? Got it, everyone?
Yes.
Okay. Let's see now, what is the probability of flipping a coin after 3 times? And you need to get the probability of getting head, tail, head. What method do you want to do it? This first one or this second one?
Can you do the second one?
The second one?
Yeah.
Do you think it's easier for you, the second one?
I mean.
Okay, just let's get the sample space.
Mm-hmm.
What is the sample space? The sample space would be hep, hep, hep.
Mm-hmm.
What is next?
Head.
Hep, hep, tail.
Oh.
What is next? Hep, tail, hep. and then head, tail, tail. Okay, these are all possible combinations. Got it? Do you follow me?
Yeah.
Okay, we have tail, head. Okay, tail, head, tail. Okay, tail, tail, head, and tail, tail, tail. This is easier to do when we have a few, you know, when we have just 2, 3, 4 at a time, you know? When the amount is shorter, we can do this one. You get the sample space and you can get easily how many times you can get head, head, tail, head. How many times you get it?
One.
Okay.
So it's 1/8.
Huh?
So it would be 1/8.
Say it again.
It would be 1/8. Yes.
1/8 because there's only one possibility that you get this way. This is 1/8. Even though let me do the same method that we do, which is this one. Remember, as I told you, when you want this order, you need to get the probabilities individually. You know, the probability of getting head, times the probability of getting tail, times the probability of getting head, and then this one is 1/2 times 1/2 times 1/2. This is 1 into how many times? 3 times. This is 1/8. Got it?
Yep.
Everyone more or less, you're grabbing those ideas?
Yeah.
All right. Let me start playing with cards. Okay, why you need to know about the deck card? How many cards we have?
52.
How many cards in total?
52.
62 cards. We have in total 62 cards. We have also out of those 62 we have 13 red. No, half of them will be red and half of them will be black. Got it? Yes or no?
Yeah.
Yeah.
Also you need to know that we have also okay, let me do it with the right color. We have a diamond. Okay. Have a diamond. We have a heart. Okay. Have you ever played card, guys? Hmm?
No.
Never ever?
No.
We have a club. Okay. This is the club. And we have a spade. The space is like something like this. Okay, I'm trying my best on it. Okay. Okay. How many cars of each kind we have?
4 per color.
No, we have 13 each. 13 each. Okay. Also, we have per each kind, we have queen, king, and jack. How we call these cards?
Face cards.
Face card. Also, we have cards from 2 to 10, and we have an ace. How many ace?
4.
4.
4 ace. Okay. Okay, let's see. What is the probability that when you pick one of the card will be red? What is the probability when you pick one of the card will be red?
1/2.
1/2?
1/2.
Remember, we have 26 red card over the 62. We simplify and we have 1/2. Okay? Okay, 60%. What is the probability that when you pick one of the card will be an ace?
4 of the 52.
Huh?
4 of the 52.
4 over 52. We simplify. Simplify that. 1, 13. This is 1 in 13. Got it? Hello?
Yeah.
Yes.
What is the probability when you pick one of the card will be a face card? Will be a face card.
4 over 13.
No.
4 over 50.
How many face card we have?
3.
Huh?
12. Or 12.
12 face card in total. This is 12 over 52. Okay? 12 over 52. Half 6 and half of 52? 26. Half 3 and half 13. This is 3 over 13. What is this number? 3 over 13 as a decimal?
0.23.
Say it again?
0.231 if you round.
0 point
231 if you round it.
3 to 1.
231.
Okay, 2, 3, 1.
3.
And then this is mean, which is 23% approximately of the cards are face card. Got everyone to hear?
Yeah.
And my
Yes.
questions come now when we have this problem. This problem said, okay, what is the probability? Okay. What is the probability of being a debt akin followed by an ace? And then we have two probabilities included. What is the probability you get a king followed by an ace?
You could just times the probability of the two.
What is the probability of being king?
4/52.
4/52. Let me specify here something. Replacement no allow. Is replacement no allow? That means for the first time I took one of the cards, right? If you took one of the cards, how many cards we have for the second option?
51.
61. And we have 4 ace. Everyone got that? Get it, everyone?
Yeah.
Okay. What is the solution?
4/663.
What is the decimal number?
0.0060.
0.006.
Yeah.
Okay. This is the probability. Everyone up to here? Are we getting this one? Let's analyze now. Okay, let's analyze now. When we have we have a marbles here, okay? We have a marbles, and then let's play with marbles. Have you ever played with marbles before? Huh? When you was a child?
I guess, yeah.
Huh? Long time ago. Okay, let's start with this one. Let's start with this one. For example, let's start the probability with replacement. And let me suppose that we have, for example, this marble right here. Okay, we have a blue marbles. We have a blue marbles, and we have a green marbles. Okay, and what is the probability when you pick one of the marble will be red? That the marble will be red.
6/15 or 6/15.
6 out of 15. What is the probability when you pick one of the marble will be blue?
5/.
How many?
5.
5/15. What is the probability when you pick one of the marble will be green?
4 out of 15.
4 out of 15. And then, let me suppose that you put your hands from the maps that we have a 15 marbles. And then what is the probability when you pick one of the marble? When you take one of the marble, the first marble would be red, the second marble would be blue, and the last marble would be green in this order. The condition is with replacement. Okay? What is the probability for being rep? We get here, which is 6 over 15 times the probability of being blue, which is 5 over 15 times the probability of being green, which is 4 over 15. We multiply all of that, we get this is 120 over 375, which is 0.035, which is mean this is 3.5%. Got it, everyone?
Yeah.
My question right now is try to get the same order, but now it's without replacement. Without replacement. Okay, let's see the order. We get red, blue, and green. What is the probability for being red?
6 over 15.
6 over 15. But we didn't replace the marble. And then how many marble we have left now?
14.
14. 14 over 5. And then how many marble we have left?
13.
13 over 4. We multiply all of that. We get this one is 0.439, which is 4.4%. Got it, everyone? Hello?
Yeah.
Okay.
Yes, Professor.
Let me go and analyze this problem. How many ways okay, how many 5 digits number, sorry, how many 5 digit number can be formed? Repetition, no allowed. Okay? By using the following numbers. The numbers are here. The numbers are here. 1, 2, 3, 4, and 5. We are using 5 digits number. 1, 2, 3, 4, 5. Okay? How many ways for the first position?
5.
It's 5 digit number. That's the reason that I put first spaces, all right? How many? This is the number. How many for the first number? How many ways?
5.
5, because I can use either or for the first 5 numbers. And then this is 4 ways. How many for the second one?
4.
4.
4 ways. For the third one?
3.
3.
4, 2 ways. 1 way. Just we need to multiply all of them. How much it is?
120.
120 ways. 120 ways, which is the same thing as a 5 factorial. Okay? If repetition is allowed, and then how will be is repetition without you can repeat the numbers, and then repetition allowed. How will be?
5 times 5.
5,
Five
5, and 5.
5 to the 5th power.
What is the solution?
Uh,
Is repetition is allowed?
3,125.
3,000?
125.
Good job. Everyone get it? Next problem. In how many ways can six be allocated to 6 people? Let me suppose that the 6 are like 6. When you go to the theater, you can see the 6 have letters, all right? A, B, C, D, E, and F. You have to allocate 6 people.
6 factorial.
This is 6 factorial. What is 6 factorial? 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. How much it is?
720.
720. Got it, everyone?
No, can you repeat that again?
Huh?
No, can you repeat it again?
What did you get from there? Because you have to allocate
the
6 people in 6, 6.
6 factorial is 6 times 5 times 4 times 3 times 2 times 1.
Yes.
So if it's 7 factorial, it'll be 7 times 6 times 5 times 4 times, like that?
Exactly.
Okay.
Okay. Let's analyze the following problem. And then we have now a conditions. And we need to be focused on the conditions. The conditions, this problem set. Okay. How many 3-digit number greater than 200, this is the condition, can be formed with the digits 1, 2, 3, 4, and 5. The number have 3 digits. Remember, in that case, repetition no allow. How many from this digit you can use in the first position?
2, 3, 4, 4 numbers.
Huh?
You could use 4 of them.
3, 2, 1.
You can use the numbers are, this one are the numbers that you can use for the first position. Which one you will be using?
Anything bigger than 1.
Anything bigger than 1. That's the reason that you can use 2, 3, 4, and 5. Because the number has to be greater than 200. Okay? The number has to be greater than 200. And then that's the reason why I have 4 ways for the first position. And for the second one?
It would also be 4 ways because
4 ways we do one already. And for the last one?
3 ways.
3 ways. Then we multiply, and then we get this one is 48 ways. Now,
Professor,
let's,
explain that again, please.
okay. For the first position, we have the condition set. The number has to be greater than 200. We have these numbers that we can combine. Okay, we can combine those 5 digits. Okay, the problem is that we can use 1 because the number and as a first position because the number has to be greater than 200. And then automatically we don't take 1. Okay, 1 we don't take it. Okay, because it's not made the number no greater than 200, you know. And then what we're looking for is a number which is greater than 200. And then we just have 4 ways for the first position. For the second position, we already took 1 on the first one, and the second one we just have 4 numbers. In the third position, we took 2 already, and then we have 3 left. We multiply 4 times 4 times 3, which is 48 ways. Let's see, for example, Vivian, when the repetition is allowed. Repetition is allowed, Vivian. Let's see what's going on. Repetition is allowed, but the conditions are the same. How many ways we can use for the first number?
4 ways.
Huh?
4.
4. How many for the second one?
3 ways.
No.
Would it be 4 again?
4 again.
No.
5.
Repetition is allowed.
5.
5. Repetition is allowed. We don't use 5 in the first one because of the condition. Okay?
Yes.
And then from the last position?
5.
5. How much it is? 5 times 5 times 4?
80.
80.
I mean 100.
100.
Professor, a quick question. And on like the questions, is it going to tell us that repetition is allowed or not allowed?
Yes, they're always specified.
Okay.
They're always specified. Always specify that.